So hello everyone, in this video I'm going to show you how to use a servo motor using SmowCode. And once again you can find this code in the template and I'll explain to you what this code does. So in the first flow we have just two nodes, which is the on start and the servo node. You can find the servo node by in the filter libraries by writing servo. As you can see, there's just one node for it, and when the ESP32 is flashed, it just keeps the servo at 0 degrees. So that's basically like an initialization for the motor of the servo to be at 0 degrees when the code is flashed. And as you can see in the properties, we have one config node, which is the config property, which is the servo motor, and then we have the angle at which we can set it. We have chosen 0 degrees as it is the first angle when the code is flashed. If we go into the config properties, we can see that you need to choose the output pin. In this case I have chosen it as output pin 15, and you can choose the motor model. So the most commonly used is the SG90 and I'm using that, so I've chosen that. And then there are different channels you can choose for the servo motor. I have just chosen the submodule 0 for now, and if you go to the advanced, then you can set various properties for your kind of motor. So the servo motor, which is the SG90, works on a minimum pulse width between 500 to 600 ms, so I have kept it as 550, and this signal is the signal which moves the servo to the starting position. So you can think it as the left limit of the servo. The max pulse width is the servo which moves it to the maximum angle. So it should be around 2000 to 3000 milliseconds for our type of servo. I've kept it at 2500, and the servo frequency is determined by how often the servo receives the movement instructions, and most of the servos work at 50 hertz, so I have kept it at 50. And the max angle is the angle the servo can turn from. So our servo can turn from 0 to 180 degree, but some servos may be up to only 90 degrees, or some may go up to 270 degrees as well. So servo motors are very useful in real life as well. They are used in automatic doors, automatic curtains, robots, conveyor belts, and CNC machines. So they have a lot of practical use, and you can easily code for those using SmowCode. And as you can see, the servo first flow is a simple flow to just start the servo at 0 degrees. The second flow is when you click a button, which is the pin 0, which is basically the boot button. It should turn on a light, which is pin 2, which is the internal LED, should turn on, and the servo should be at 0 degrees. If it's not at 0 degrees, it would turn from 90 to 0. As you can see, I have two outputs from the on click, and those two should run parallelly. That is one of the feature of SmowCode as well, that you can have multiple outputs and they'll run parallelly. Then there's a delay of 3 seconds, and once again there are two outputs. The LED turns off and the servo turns to 90 degrees. So when you click a button, if the servo is not on 90 degrees, not on 0 degree, it would come back to 0 degree, wait for 3 seconds and go to 90 degrees and stay there. So this is a simple code, and we'll see the output after uploading it to our ESP32. So let's just upload the code to our ESP32 and let's see the output in just a moment. So this is a servo motor right here. We have uploaded the code to our ESP32, and according to our code, when we press the button, the boot button, it should come back to 0. It should be on 0 degrees, and then after delay it should go to 90 degrees. So let's see what happens. Now it's back to 0 degrees, and as you can see, After 3 seconds it goes to 90 degrees and stays there. If we click on it again, the light turns on, it goes to 0, and then it goes to 90 again. If we restart the ESP32, it should go back to 0 degrees and stay there. And as you can see, it's back to 0 degrees, and we have successfully uploaded the code for the servo motor, and it works perfectly using SmowCode.